Okay, to show that anything is a factor of something else, what we want to essentially do is, a factor means that it divides evenly into the other thing, which means we should be getting a remainder of 0. So there are a couple different ways you can check that. You can do long division and look at what your remainder is. You can do synthetic division and look at what your remainder is. Or you can use the remainder theorem. The remainder theorem says if you're checking x plus 3 to see if it's a factor, you would plug in -3. And whatever you get out is what the remainder would be. So if I'm looking for it to be a factor, I'm hoping that I get out 0. So let's do this way. If I plug in -3 to here, plugging in the opposite of what is in the parentheses here, then I would get, it would look like this. Okay, so -3 cubed is -27. -3 squared is 9, positive 9. -25 times -3 is positive 75. Think about quarters. Okay, so 2 times -27 is -54 minus 9 plus 75 minus 12. So -54 minus 9 is -63. -63 minus 75 is positive 12 minus 12. And so you see here that we get 0. So if I plug in -3 and I get out 0, that means that the remainder is 0. So this work would prove that x plus 3 is a factor. Now if we could do this a separate way, we could also use synthetic division. So if I do synthetic division, I would put -3 in my box from my divisor, and I'm going to put the coefficients out here, and I'll set it up like that. Remember, whatever's over here is my remainder, and I'm hoping that it's 0, because if it's not 0 here, then it's not a factor, and I did something wrong because it says to show that it is a factor. Drop down your 2, multiply, and then add vertically. And then multiply, and then add vertically, and then multiply, and we see that we do in fact get that 0 that we were hoping for. So again, this work proves that x plus 3 is a factor, or you can use the remainder theorem like we did over here. So you can use synthetic division or the remainder theorem. Either one works, whichever one you like better.